Hey everybody, this is Larry. This is day 7 of the Legal Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. Today we have a hard problem. So we will see how it goes. Today I went for 2 runs. So I'm a little bit pooped, a little bit tired, a little bit, just, I don't know. It's the rule of threes, but which apparently is now an AI thing, but I don't know. But it's been like a writing thing for a long time, so I don't know. But I went to do my tempo run, but I kind of failed because it was just too tiring, too hot. But I still did it. 7 miles, 5 miles tempo, and then in the afternoon, and then in the evening after I rest a little bit, I went for 3 easier miles with friends and stuff like that with rest. So it was okay. It was fun. So 10 miles total today. Okay, just try to make sure I eat well and eat enough. I think that's the thing. And get my creatine actually. Now that I remember it. So that's kind of my workout. So it's very tiring. Do hard things. And today we have a hard problem to do more hard things. Alright, let's take a look. We have 3348 smallest divisible digit product 2. You're given a string num in which represents a positive integer and an integer t. A number is called 03 if none of its digits are 0. Return a string representing the smallest 03 number greater than or equal to num, such that the product of its digits is divisible by t. If no such number exists, return -1 and is a string. Okay, let's take a look at the constraints. So it could be a number of 2 times 10 to the 5th number of digits, so a lot of digits, and t can be pretty big too. Go up to 10 to the 14. So it has to be. So yesterday we kind of said, made some rules about t being single digit and stuff like that. None of them seems to apply because, we're going up to 10 to the 14. What is num again? Smallest 03 number greater than or equal to num, such that the product of its digits is divisible by t. Okay, so first of all, right? So there's stuff about digits and stuff like that. We'll figure it out. But the first of all is that, well, the digits can only be of 2, 3. I mean, technically 4, which is a multiple of 2, 5, 7, and 9, which is a multiple of 3, right? And 1s, which obviously doesn't factor into the product, but at least it could pad out the digits, right? So then the next thing we're trying to do is given this t, this is going to be annoying though. We're going to see if it contains a divisor that isn't, or not a prime divisor that isn't one of these numbers, then it's already no good. That's my observation. By the way, just to be clear, very often I already know the answer. In the sense that some people cynically would be like, Larry, I've seen this problem before. Of course he knows the answer. And maybe that's true. But I mean, I've done like 3,000 problems just on Leetcode. I've done probably 15,000 problems in my life. I don't remember all of them, right? It's just that a lot of problems I am able to figure out on site. Like, what they call in rock climbing, flashing it. Like I'm able to flash the answer and I'm able to explain it. Like, well, at least like 90% of it. Sometimes I'm missing some details that I know that I could figure out. I just have to, and sometimes I'm wrong about it, but still. This one, the context of that is not to brag, but the context is that for this particular problem right now, even though I know that I've also solved it, but I don't remember when I solved it, like 2 years ago. So I don't remember this. And I don't know the answer. I mean, and I'll be honest, if I remember it, I'll just be like, I remembered it. And that's why I know it. I don't remember this. So everything I said so far is a live proof of just me thinking through the problem, right? So this is going to be a live solve, just to be clear. That's what I'm trying to say. But yeah, so with no regards to nums yet, if it is divisible if it has a prime divisor that isn't one of these, and then unless I messed up one, I think I skipped 8. I didn't talk about 8, but 8 is obviously just 2. Yeah, if it's if it doesn't contain a divisor, if it contains a divisor, a prime divisor that isn't one of these numbers, well, 1 is not prime, but whatever. I'm pedantic, but that's what you need to do to these kind of things. Then it's just not possible, right? So maybe you could write something like, I'm so tired. I don't know why I almost write out prime, in case you're wondering what I'm trying to write out. But so right? Maybe we'll write current is equal to t, just in case we do need to save t, right? Then like I guess we don't have to do it this way, right? I guess we can just write for pf for prime factors. We can write for p in pf. Mod p is equal to 0. Current right? And then if current is not 1, then we just return -1 or string of -1 for this one for some reason. Well, I mean, for some reason, because it could be a lot of numbers, right? And then the rest is that this is the only impossible case, right? The reason being that you'll always find an answer because you can always just pad 1 in front, right? So now we have some sort of an answer, but then now using the prime factors, and maybe we could I mean, you know, it's not, we could still change the code, is that yeah, given these prime factors, how do we construct? So there actually there are 2 components, right? One is the minimum number, which is you know, for example, if the number is 8, you need at least 3 2s, right? Or 1 8 or something like that. And so that's the minimum number. But we can also add just more digits in general, because we have to get the next biggest one, right? Smallest 0 3, right? So this part I think is straightforward so far. Now the tricky part is we have to figure out how to figure out the minimum number, right? For example, 256 is what, 2 to the 16 or something? Is it? No. 2 to the 10 is whatever, right? So 2 to the 8, right? And then you have 3 3 2, and then you have to do some permutation so that this is slightly bigger than this, right? Because I'm trying to think if there's a good way to enumerate this, right? I mean, the answer is probably just some like oops, I'm quitting my keyboard, my bad. My first guess on how to approach this is just by greedy, right? So I would be like 1 digit at a time, and I do wonder if well, there's minimum number of digits, right? So what I would do, and maybe we could write it out actually, right? So I should say f is equal to, I'll just put it in counters. There's only 4 elements, but right, f of p we increment by 1, right? So then now the smallest number, right? So we start with the smallest number, maybe it's going to just be for p in pf again, right? So we have f of p. So this is a number. We times that by the string of this, and then we have the answer, kind of maybe possible answer, right? And then we have return. Oh, it's not a return yet. We have right? So we have the string. Right, so let's just say answer string, s is, okay, answer string, maybe? I don't know. So then, if the length of the answer string is greater than length of num, or length of num is equal to length of answer, and num is greater than, or the other way around, answer string. Let me put the paren so it's more clear. Then we just return answer string, right? This is saying that, so answer string is the smallest possible number because it's constructed by all the prime factors. Is that true actually? No, this isn't quite right. The reason why this isn't quite right is because it's not condensed. Meaning we don't do the 8s and the stuff like this, right? So this isn't quite precise, right? For example, if your I don't know, if your T is 2, no, if your T is 256 even, right? And your string is actually, I mean, just example 1, right? Example 1, what this does is that will just construct a string that's like 6, 8 2s or whatever. And that is obviously not the answer, right? Because there's this answer. So we have to just compress it a little bit. So one at a time, right? This is kind of awkward. This is annoying. And we have to do 6. So the smallest. Well, okay, fine. I'm just trying to think about how to implement it. I mean, the idea is probably fine. I don't know if it's even. Honestly, I don't know if what I'm doing is necessary, but it's fine, right? Trying to think. Okay, let's just play around with it. Yeah, okay, I don't know. It is gonna be way awkward, but so we have 9, which is just 2 3s, right? We have 8, which is 3 2s. We have 7, which is just 1 7. 6. Oh, 6 is kind of awkward, isn't it? Huh? Damn it, 6. Alright, fine. I don't want to write like a lot of if statements, but I guess we'll have to do an if for 6. But yeah, so we'll just say for P in range from 9 to not 1. So I always forget whether this includes the last number. I don't think so. So 1 should be fine. At least when I mean, I know that it doesn't when I'm counting up, but counting down, I'm always just confused. But yeah. So yeah. So if P is in lookup, then if f of lookup of P of 0. Okay, so count is equal to this. F of lookup of P of 1. No. No, we don't do an F. Of 1, that's the count. No, that's the thing that we're doing. So, this is the number, this is the count that we have, this is the need that we need, right? So that means that we I mean, I know what I want to do, but then we manipulate f, which is not what I really want to do. So that's why I'm a little bit wary. No, okay. I mean, we'll just write it out first. I mean, it's fine. We'll just do something like, where I have it? Like, I don't remember f dot copy works. Right? So, because I don't know, I guess we should be okay because it's not a deep copy, but we don't need it to be a deep copy, I don't think. Right? Okay, so then now we do need, so we need that. So we need this, how many counts? Oops. Okay, let's just call this half. This is how many we have. This is how many we need. Count is equal to this. So then current f of look up p of 1. Oh. Huh? That's not. We need 2 threes. I think I did the. That's what I was. Okay. Okay. So we have that many counts. We need that 2 of them. Okay. Yeah. Okay. Fine. So then now we subtract that. By count times need, right? And then answer dot append count times p, string of p, right? I think also I'm doing it backwards, so I have to reverse it, but that's fine. My goal is to get at least example 1 right, kind of. I say kind of because I don't think I'm gonna handle the 1 correctly, but yeah. Otherwise, if p is in pf, meaning it is one of the prime numbers, then we just half is equal to current f of p. Need is equal to 1. I don't know why I wrote it this way, but I guess so that I don't have to so I don't have to think. Okay, and then else p is 6. Right? Let's just assert p is equal to 6, I suppose, for us. And then now we have half is equal to min of current f of 2 and current f of 3. Need is, well, we just have 1 of, well, that's how, alright, so that's the count. Answer dot append count times string for p. What we want then now is to subtract count. Current f of 3 is also subtract count, if I could spell correctly. And there we go, right? And then now answer dot reverse. Print just this, and then the rest. I guess it's not true anymore. Oh, well, okay, fine. Not yet. I was hoping to go to sleep early, but yeah, okay. So okay, so 488 is what we expect, to be honest, or I expected anyway, because like we said, we didn't handle ones, right? No, okay, yeah. But if it's greater than this is already done, right? And I think maybe one of the answer actually, okay, okay, that doesn't show it. But how would I say that? So 256. Oh, say 1 actually. String of 1 for this one. Oh, okay, I didn't know. Why can't it be 1? Oh, the length is. Why does the length have to be double digit? Does it matter? It's just the next. I guess there's some like weird single digit case. Maybe that's why. But yeah, as you can see, 488 is the answer. 488 is expected. We are done if that's all we need. But the thing is that we now. So yeah, so this condition, no, I think is right, meaning that if the smallest number, if the number of digits is bigger, or if they're the same, and this is, the number is smaller, you could add an int to it if you like, or you convert to int, at least in Python, right? But it doesn't really matter. The string comparison is fine because they're the same length. I do wonder if this is fast. I mean, I guess it doesn't matter. We could just also write like if int of. I mean, if this is time critical, then we would benchmark it. But I think it doesn't matter too much in terms of timing, at least in Python, right? Obviously, right? So yeah. So then now the hard part, of course, is finding the answer. Now that we know the answer, I have a hypothesis, which is that the answer has to have the same number of digits, or as num, or number of digits plus 1, right? Why do I say this, right? So well, the number of digits plus 1 thing is just, just by default, you could take any number or any smallest thing and then just add 1 to it, right? In this case, for example, in Q1, or test case 1, okay, so we have that one, but we could have also have like 1489 maybe, right? I think the answer is actually 18 something, 1848, I suppose, actually. Yeah, but you can also imagine that given 488, one possible candidate is not the correct candidate for the smallest, but one possible candidate is just 11488, right? And that would be, a possible candidate is not the answer, obviously. So we can always do the number of digits plus 1. Yeah, right? And this is assume, of course, just to be clear, stepping back a second, this of course assumes that this conditional is already, we already checked for this, because if it's already bigger than the number, we assume that, okay, let me add an annotation here. Answer contains the smallest possible divisible, smallest possible number that is divisible by t, that has a possible number that has a product, whatever, meaning that has a product divisible by t, right? So if the smallest number is already bigger than your num, there's nothing in between because this is the smallest number, right? So that's why. So we remove that. But if it's not the smallest number, then there are two cases. The answer has to have the same number of digits as num, or the number of digits plus 1. And as I said, the number of digits plus 1 is already just, you add 1 to it, right? You already have the smallest numbers, so the smallest number in general. So if you have the smallest number of k digits, the prefix is just going to be all 1s, right? Because that's the smallest number with that many digits. That is the smallest divisible digit product equal to t, right? Okay. So then now the problem comes down to the first part. The answer has to have the same number of digits as num, right? So okay, so maybe I write. I mean this or yeah. So then maybe this will be our default, right? It'll be so we have pad is equal to, we have the length of the shortest answer, or the other way around. Yeah, length of num plus 1 minus this is the number of extra padding that we need, and we can just write 1 times pad plus answer. I mean, it's not quite clean, but whatever, it's fast enough, right? Yeah, I mean, this is what we expect, right? I mean, it's not the right answer, and we can maybe, how do so yeah, just for proof of concept, we can do like 9999, right? And then you could see that this, yeah, the smallest number of whatever. So then the question becomes, right? Is there a number that is bigger than num that has divisible digit product equals to t, right? So that's what this problem comes down to. And again, everything I said so far, we're working step by step. I'm able to see a little bit ahead while I'm trying to explain, like for example this part. But you know, everything's worked out, right? And for here, my proposal is just going to be greedy. A greedy check rather, right? It's almost like those lexicographically smallest thing, right? So one of those checks. And what I mean by that is just, okay, now, I mean, we know how many digits we need in our proposal, so then we just have to fill it out, right? So maybe we write, I don't know, digits is equal to just none for now times, is it, did I call it n? Actually, because I didn't label it. N is equal to length of num, standard stuff, right? So n, right? So then now we literally just try, or we can, right? And this is why I didn't want to use the current f part. I actually initially thought that there is some like the additional trickiness, but actually I think I'm wrong, in the sense that this is easier than I expect, because I forgot. I was thinking about this earlier when I was talking, but I actually forgot that you can just pad it once. So what I'm, just to give a little context, stepping back a second. So in a lot of these lexicographically smallest problems, you have this. The idea is that you brute force try one number at a time, one digit at a time with one number, and so, but the problem is that some of them mix the rest of the things infeasible, so you have to try the next number. But for this particular one, you can just pad with one, so it's always possible, even if you used all of the f's, all of the frequency table things that we have here. I actually do wonder if, let me print f for a sec. I don't know if it's a, like, I don't know if it gets copied, that's why I'm curious. Like, yeah, okay, so yeah, because I mean I know it gets copied, but I don't know if it copies the same reference. Like, that's what I was curious about. That's why you have to, these things, I mean, I just know enough to check, right? That's why. Yeah, okay. You see, they're not the same reference. That's what I'm checking. The only thing that you can do is just if you don't have f's, right? So here we go for I in range of n, right? So one digit at a time. And then we just go for D for digits in range from, we go just from 1 to 9, right? And then here we go, the thing that we have to do, and maybe there are multiple ways to write it, is that we have to go to the prefix as long as we can. So maybe I'm not going to write this quite like this, right? So maybe I have something like done is equal to false, right? Are we still following the prefix? The idea what I'm saying is that, for example, if the number is, I don't know, the example, right? 1, 2, 3, 4, then the first digit we're going to try is 1, right? Yeah, but if it doesn't work out for whatever reason, then we have to kind of figure out how we detect it doesn't work out. How do we do it without recursion? But let's just say there's a magic function, and we have to think about it. So maybe it's not that easy. Then we could try 2. But the thing is that now, if 2 works, like there is a physical, it's possible, then the rest doesn't matter because we can just throw it out with the min of the rest, right? It doesn't really, you know, I mean, maybe just whatever, but yeah, I think that's fine. I think okay, so what is the impossible thing, right? So let's say we start at 1. What makes the rest impossible? The rest is impossible if you have too many digits, right? Meaning, for example, if again you have the same thing as, well, I mean, we could just walk it on the first example, right? We try 1, we know that we have 8 twos, oops, 8 twos, right? Putting a 1 here means that it's still feasible, so we are good, right? I mean, we'll have to figure out how to handle it because there is some like weird dynamic programming problem. Because, and I don't know if I'm like overthinking it. I think that's part of me trying to like sanity check myself. But anyway, with just 2s, I could show you my logic even if it doesn't, right? But then here we could say 2, right? Because it matches the prefix. But the thing is that then now, even if you put A8, you still have an extra 2, so this is not possible. So that's basically what I'm trying to do, is that we walk 1 at a time, right? And then eventually you're like, okay, well 3, well we have no 3, so we can't even take a 3. But 4 uses two 3s, we have 6 2s with 2 digits left. This is possible, so then we're good, and then you just kind of do it that way. But then now I'm thinking like, how do I do it? Is it just greedy? Because my question now is, right, let's say you have 6 2s, 5 3s, I don't know, whatever, right? Then the question is, how many digits can you use? Like, what is the smallest number of digits that you can do? Do I just do DP? And the hard part is the 6. Damn you 6. Because without the 6, then you can just do 2 2. You know, 2 2s is a 4, 3 2s is a 8, right? So 4, and you know. But I'm trying to think because there's only 3. So if we greedily, because the thing that I'm because and the 2s and the 3s are and the 6 therefore are the only thing that matters. I'm trying to think like, is there, do I have to do DP or or there's just a rule? How many digits do we have? We have 10 to the 5th. 10 to the 14. So what's 10 to the 14? Well, 10 to the 9 is 2 to the 30, say. So 10 to the 14 is 10 to the 40. So that means you have at most 42s, and you have, I don't know, you don't even have to think about it, but at most 43s. So then we could just do a DP, right? Does that seem reasonable? I guess so. Alright, let's do it then. Yeah. I'm just trying to name the thing. I already named things F for a function, but let's just say get min digits, say, right? You have 2 and 3, right? So we'll memorize this. And this can actually be memorized in like a global level if you really prefer, because it doesn't change, right? So then now, and maybe, like I said, maybe there's a easier greedy, but I will have to think through it, and it's not great. Otherwise, best is equal to infinity. Infinity somewhere. I'm lazy, right? Right, then now we can take, if 2 is greater than equal to 1 and 3 is greater than equal to 1, then best is equal to min of best get min digits 2 minus 1, 3 minus 1, right? You could also do 3's, right? So if 2 is greater than 3, then get min digits 2 minus 3, 3, right? Otherwise, then you do an L-Swift. If it's greater than 2, we do the same, but with 2, basically you're putting in a 4 in a digit. Of course, if this will mean, technically I will greater than equal to, but that means that this 2 is exactly 2, right? And then else, best is equal to min, best get min digits, and then now you have, I forgot to add a digit though. So we're just gonna return silly. Okay, plus 1, right? Otherwise, then it just goes to 0, right? I guess we should check if 2 is greater than 1, because otherwise I think it goes infinity recursion. Silly boy. And the same thing for 3, really. And you could probably use this with a for loop, but I am I don't know, I am a silly boy, I suppose. 2 doesn't change, 3 minus 2 plus 1, this is for 9, else if 3 is greater than 1. I don't know, why am I writing it like this? This is like nonsensical. But we already mostly done, so right? Then we just return best, right? So that will get us the number of digits for the 2 and 3. Okay, right? Okay, then we're happy, right? So for J is in range, we wrote this and we deleted it, but okay, so is this feasible? Oh, the reason why I didn't write it is because then now, if not done, if the prefix is not done, then we start at we start at the prefix, I suppose. Yeah. So I say prefix because I'm thinking of digit DP, which is what I call the prefix. But so for J in range from the int of num sub I, is it num or nums I all the way to 10, right? Well, I guess if it's not done, we just do. I don't know. This is, I'm writing it in a poor way, and I'm not thinking clearly. But oh well, right? So okay, so then now we try, right? How do we try? We go. Well, first we check. This part is so annoying. Because we have to rewrite all that like this weird logic again is why. And this one's annoying. Or this one is either annoying or I'm not good enough to do it cleanly yet, right? Okay, then let's not write it this way. If I'm going to write it multiple times, then yeah. All right, so start is equal to 1. If not done, start is equal to int of num I, right? And then now we can write something like this. So at least we dedupe there. Yeah. I'm just gonna copy and paste this a little bit. Okay. Okay. So then the idea now is, okay, so we try. So what we do now is okay, so then now we try, and then now if possible, or if possible, I mean, we could pass F, it doesn't matter, but F, the number of digits left, or maybe we write it, get min digits of F, right? So digits is equal to this. If number of digits is greater than actually this is nonsensical, but maybe that's fine for now. Because I think as soon as you're done, yeah, because as soon as you're done, you just do it with the min of the rest of the numbers. So I don't think that makes sense. Okay, fine. Okay. Okay, so if the number of digits, so that's if the number of digits is less than or equal to n minus I minus 1, because we just used one of the digits, then we're good, right? So this is good. So then that means that we get to continue. No, we get to break from this one, right? Otherwise, maybe we write good is equal to true. No. And we found one. So then at the end, if not good. Wait, what? No. By definition, no. Yeah, okay. If not good, then we break, right? And when we break, then it goes to the default thing. It just means that a number of that digit is not found, right? But if it doesn't, then we just go to the next digit and we start from the start. Well, kind of. Okay, we also have to fill out digits of I is equal to, oh man, did I name two things digits? Okay. C digits. This is terrible. Okay, it's equal to P, good is equal to true, and then we break, right? Same thing for here, but it's not quite right. What am I doing? It's not this count minus need thing, right? This is just one of this, right? So you have one, so we have this. We don't even look at it, right? Well, okay, fine, we do look at it. But if so, we need this many. So if half is greater than or equal to need, yeah, if half is greater than or equal to need, then we, yeah, I mean, it's basically, yeah. Okay, so we subtract only one instant, well, one copy of the instance, and then now we try to get the number of digits. Okay, same here, except for we already have need is equal to 1. So that's a little bit better as well. And this is all inside, right? So if it doesn't, then we just continue. And also, as soon as you skip any number, that means you're no longer in the prefix, even if anything is true. So that means that, okay, so maybe we write something like, skipped is equal to false. So we write skipped is equal to true. So as long as we, if it's not equal to start, right? I think the logic is fine, but I'm not happy with the implementation, right? But that's maybe okay. Okay, so then now p is equal to 6. So then we just write custom if this is f, not current f. Okay, so if f of 2 is greater than 1 and f of 3 is greater than 1, then yeah, then f of 2 f of 3 and so that, ooh, oh, I just kept that. I don't think I need it. Doesn't really make sense here. I really didn't look at the code. Okay, I just copied it. Good morning, what's it, San Diego? Okay, digits of I is equal to p, which is a 6. Good is equal to true, we break. Else, skipped is equal to true, we continue, right? And if it goes by or by, then yeah. Otherwise, if not good, we break. If we skip, then now we fill the rest with min, with the smallest that we can, right? How do I do that? Yeah, I mean, I guess this is just this function, right? That we have here, actually here, which is okay. Do I just rewrite this then? Yeah, okay, fine. Def get min number of current f right, and then s is equal to get min number of f dot copy, right? So we don't need to write it this way. It's a little bit awkward the way I do it, but I'm just trying to get it done and get it to sleep. Yeah, then it is actually, in this case, I don't think I want to write it this way anymore. I just write an empty array. Digits we append p, and digits we append p. And I actually want to append the string version of p, not just p. Okay. The other thing is wrong, I know. Hang on. Okay. Sorry, my eyes are getting tired. Okay, so then now we append, what's it called? Get min number of f, and we are good, kind of. I mean, we still have to implement get min digits, right? Also, we didn't do it here. We didn't do it this here either. I just kind of forgotten about it. And I forgot a couple of things. Hang on. I've forgotten the else part, right? I mean, there's the skip part, and I just forgot the else. We just kind of put this back in, right? So that it can be used. This is one. My eyes are like burning. I don't know. Maybe I need. I don't think my AC is on. Okay. Unhashable type. Get min. I didn't implement get min digits, did I? Oh, I did. But it's a different get min digits. I am a silly boy. Why did I name things weird? But okay, it's fine. I'll actually do a get min digits for counter. But then this one, maybe I'll just write that shit, something like this, right? But it'll be called by this one. I don't know. Look, I've given up on any semblance of clean code. My apologies. But yeah, but this is going to be just. Oh yeah, this gets the number of digits. So then, oh yeah, no, this is the number one. So it's not the if statement. So then now we just do for. So there's no 2 and 3, so it's just 5 and 7, right? So I think this is wrong. No, I think this is fine because of this part. And number 3, okay, yeah, no, okay. So then count is equal to get min digits f of 2, f of 3. Can we increment by f of 5 plus f of 7, right? There's no multiples of those, so, and then that's it, and then just return count. I forgot that this is, we named it to get digits 2, 3. Take one precision. Oh, which one? Oh, because it is recursive. Okay, I mean, it looks like you know, it always skips to the next one with the more digits. So something is wrong. Ooh, this one was okay. But oh no, I intended it. No, yeah, I remember that one now. That was so long ago, I forgot. But that means something here went wrong. So that's why we have a break on good. If not good, we break. No good on I, and then digits maybe just to see where it's breaking. It doesn't go that far. Am I missing something? Did I forget to call something? Let's just check real quick. Oh man, my eye. Here, okay, so at least that happened. We go into the loop. I mean, okay. Does it just go for all of them, or did I mess up? Okay, so it tries. Wait. Oh no. I is the number of digits. That's fine. Digits, it's 2. So we do a 2, and then eventually it's just not possible because it. Why doesn't it try a 1? So it goes here. But why? Good, skip. And did I mess up N? Why doesn't it go anywhere else? Oh, now N is 4. Okay. So it's good. But then we skip. Oh, so it. Oh, I'm just dumb because we append it and then we just break. I think we're supposed to return the thing. It looks wrong because it doesn't have a 2 prefix, but we can fix that. Yeah. I mean, we're getting closer. I think we just I think I just don't handle the one case, right? Because one is I think it checks if one is in PF or something. Because well, I guess it's not in PF. But for one, it actually does the P is equal to 6. And I had this in the earlier spot because we skipped 1 in that case. In here, we skipped 1. But here, I forgot. I just didn't think about it. I just copy and paste, and I didn't keep the assert equal to 6. And you can see that that's what happened because we didn't check for 1. Okay. So if P is 1, then what do we do? Then we're just good. I mean, if the rest of the digits, right? So, okay. So if fp is equal to 1, c digits is equal to get min digits of f. If c digits is same as all the other parts, then digits dot append string of 1. Good is equal to true. We break. Otherwise, well, we don't have to increment anything back, but yeah, I think we're good. Now, and then here we have to skip this equal to true and then continue, right? Yeah. This is a confusing loop. Okay. So we did a little bit better here. That's good. Here, why are we wrong? So we did a 1, 1, 4. Why does it try to do a 4 in the second digit? Wait, what is the input? 1, 4, 8, 9. Oh, I see. Why did I test this? But it's a good thing we tested because I don't know, right? Did I create this one? No. So yeah, it seems like our possibility thing, the get min digits, is not enough because you could the rest of them could be. How did I fix this? I didn't think about it. I was wrong about. I missed the case. It's basically it tries to do 1488, but then it's not good, so then it just takes the next digit, right? Because it couldn't do 8 on the last digit. But the answer is actually, yeah. How do I do that? How do I fix that part? Honestly, I don't know right now, so I have to really think about it. I for some reason I really did forget about this case. And it's a good thing it's in there. Because I thought checking the number of digits is good enough, but it's not. Well, it's just not true, right? We're so close. I mean, we're still like an hour in, so we got a little bit close, but it's not so great. But I'm trying to think whether like I have to rewrite a lot of stuff or is this good enough? I thought we were done. I'm not gonna lie. I mean, Alright, I'm gonna use the restroom real quick. BRB. I'm gonna think about this. Okay, so I think I have an idea, but I don't know how to get it fast enough necessarily. The idea is that, okay, so in order for, so the idea, I mean, the principle about this lexicographic thing is that, is it possible to still fill out the rest of the digits, right? And it's possible if, one, you can use all the digits, so it doesn't, all the digits have places to go. The other is that obviously there exists a solution that is bigger than the smallest one, right? But it doesn't, so the idea is that, for example, if you have 488 left, like we have one 488 and we did 1, the idea, the idea isn't that we, I mean, I only checked for the digits, so that was my mistake. But the idea is also to check, because you only need to prove or to show an example where you have to show an example where it's possible to fill out the rest, right? Given the 1 prefix. And the way to do that I was able to come up with is to have the max, right? So if 488 is your min, which we have like calculating, then the max is just 884, right? It's just the reverse of it. It's greedy in the other direction. So okay, so I think that idea makes sense. The problem is that it takes linear time, right, per digit, and so that makes it quadratic, which is not fast enough. Which is why so I was able to come up with this, which maybe is not that, I don't know, another thing, maybe it's not that impressive, but I don't know, I didn't know how to do it 10 minutes ago. But still, it's O of n, and that is not great. I'm playing around my head about some properties about like monotonically increasing digits, because if they're not monotonically decreasing, then by definition you should be able to have one. But I don't know how to kind of be precise about it. And it has to be the next one anyway, right? Oh, greater than or equal to. Equal to is actually interesting, but I mean you could just add by one if it's not equal to. But him definitely missing an insight, or maybe I'm just approaching it the wrong way. Maybe we'll. Okay, I was gonna say maybe we could take a look at 50, because that was the other case I was wrong, right? But how did I miss the 3 in here in the answer? That's kind of confusing, actually. Did I miss the 3? Oh, because basically we did a 5. True. Huh? I wrote P. Did I? No, I did P is fine. I forgot if I did P or J, which sometimes isn't the thing that wicks me being dumb. But okay, so after 0, why 5 and not 3? Of course it got skipped then. Did I mess up on the 2? Because it goes through the 6, that's why I'm double checking. Otherwise the 2 would be here. 2 if... I was hoping that maybe there's an insight that I missed. That's a 2. And why doesn't 3 work? Huh? Alright, let's just put out F as well. You have 2 5s and 1 2. Is that right? Oh, well, that's on the 50, not 1 2 3 5 5. Did I misunderstand something? I mean, I get that there could be additional numbers, so maybe I'm missing some. Because obviously a multiple of whatever is. Maybe it's just easier than I think. Then I'm just being dumb. Right? I'm trying to figure out the principle, because I think I am incorrect in even if my other ideas are correct. I would have tried to do 1 2 5 1 5 or something. I think I missed the 5 though, because I have to do the number of digits or whatever. But because I forget because what happens is that I'm solving for exact. So instead of 3 times 50, which is what this number is, I solve for exactly 50. So how did I get the 3 in there? Huh. down the wrong path. Maybe I'm doing it really wrong, because I don't know that the way that I was doing it could do it. Well, even if I figure out how the reverse thing, I'm not right. So that's my that's the issue. Well, one of the issues anyway. Huh. Wow. Maybe I should have looked at example 2 first, because okay. Wow, now I have no idea, to be honest. So I'm trying to think. If we can construct it another way. I mean, the naive thing is just to check whether this is whatever, but that's not really, it's okay. How? What am I missing? I wrote a lot of code for things that don't even work. I mean, this part is the only part that I'm confident about. And even then, I don't know how to use it anymore. So this represents the minimum. I mean, I did talk about one that it can be more, but I kind of just messed up after that. I forgot about it. This is 2 times 13, so negative 1 is going to be right. Okay, 2 times 5 times 5. And then now this becomes the lower bound requirement. I mean, I think I could work around it, but I still don't know how to handle. Okay, I mean, I think I it's not that bad to handle this case. We just have to yeah. Like, I think we can just change minor things, but this case I don't know how to change. Because how do because it tries to do the 4. but yeah, so 1 is good. The 4, it looks at the rest, is no good. And I don't know, maybe there's some like Pythonic string thing that I can abuse, but I don't want to do it that way. That's why I'm trying to think. Because it's going to be n squared if we do it the way that I think I want to do it. But there is only like 4 prime things, right? 10 digits. Maybe there's a smarter way to write it. And the next number might not even, right? Because, I mean, in this case it is, but for example, you can imagine, yeah, like if the answer is, well, I don't know, like it's not a rearrangement of the numbers, but not just anyway. What am I missing? I think I'm missing an idea. Is it Steve? Is it prefix? Is it just deep? Like, is it digit DP? And I kind of didn't realize. Can I do this with digit DP? What would that look like? The reason how I came up was I saw a 10 to the 14th again, and that means that again that means that there's 42s, and we kind of wrote that here somewhere, right? But what if we just extend it to 2, 3s, 4, 2, 3, 5s, and 7, right? And then the index, right? And number of 2s is like 40 or whatever, 50. But the number of 3s goes down a lot, 5s is a lot. So even if you have like 40 to the 4th times the index, okay, times the index would make it impossible. But and path reconstruction maybe. But no, but you can't do it if it's index, right? Okay, let me do the math. What is 5 to the 10 or something? 5 to the 10. No, 5 to 10 is not big enough. 5 to the 20. Is that, I think that's about right. 14 digits. So there's 25s, but not all of them are possible. Okay. No, but it's still, I mean, maybe by itself it's fine. But if we add an index, it's going to be too big. So it's not digit. Is it digit DP though? How would another digit DP work? Look at the prefix, look at the suffix. And you take it off the requirement, yeah, because it's digit DP. But no, I don't think it's digit. Oh, I can't get digit DP to make sense in my head. Oh, I have an idea now. I have an idea. Okay, so maybe I can just do it with a stack. Okay, does that make sense? Maybe. Okay, so the idea here is that I'm still trying to prove it to myself a little bit. But the idea here is, okay, let's just say we have given more digits or whatever, right? Or whatever, like just 4 and 8, right? The idea here is that if we want, let's say in this case, the sorted answer would be 1 4 5 8888, right? And then of course, here this is too small, right? Even though this is possible, right? Well, one is we have to figure out how to check that, but I mean, we would probably actually, maybe this is not quite the best example, I don't know. But we'll do 4 8 4 8 4 8. That's just because it's the prefix. And then let's just say this is a 9, right? Like we had before, so then 4 8 8 won't work. And then but the thing is that if because we could do it on a stack, or you could think about it as a recursion, because the thing is that if it doesn't work, we just go back 1, right? Like there's no branching. There is a branch, but it's not a branch. It's only a branch on each digit, right? Because we know that, let's just say we're here, right? We know that if this, we know that we have enough, or we know that it's still possible in the number of digits, right? Like we can fill this out. But what that means is that okay, I think I think I see it. Even though my code is a mess and I would have to clean it up even more. But the thing is that here we recurse, we're like, okay, 8. So that means that we have to try the next number after 8. There's no next number after 8. But the 4, we just try an 8, and then we're good. The thing that you might worry about, or I do anyway, is that the thing is that if you do a prefix 8, and by definition this 8 is bigger than this 4, that means that no matter what you put in the rest will be good enough, assuming that you still have the number of digits. So then you just have to go back enough, right? So let's say even this match for some reason, I guess it can only match if, like, I don't know, let's just say this is a 9. No, that doesn't make sense, but I don't know. But you would only just keep on going back and then kind of basically doing an increment, almost like an experimentation type thing. So maybe you could even be a little bit smarter. Like I said, with experimentation, instead of going back like a stack, you have this, right? How do I tell? So skip is equal to true. What skip is equal to true? It means that we skip the number. Okay, and then we just do the min. but that's not no longer true. Maybe. Okay, fine. I'm trying to think whether I could be a little bit smarter with next permutation. And whether that's even true, that because we already, all this stuff that is what would it look like if it's 885? Well, then it would actually be earlier, right? Then it would be, if it's 885, we would actually be maybe here. Here we would still do 88884, right? So maybe we wouldn't. Oh. Yeah, maybe next permutation doesn't make sense. But what we do is just that we recurse back, right? Okay, I think that works, because as long as this gets incremented in a way, or if it's possible to increment, then that means that the rest, because we already shown that you can do it. So okay, I think that's fine. Maybe I don't like the skip idea anymore. Though it's true that maybe it's still good, but I think we have to, okay. So how do I want to fix this? Okay, first we make the digits not required, right? So we'll fix the example 2 case first. Let's actually not delete this then for now, because I don't want to, I'm a little bit confused. But okay, that means that this doesn't have to be true anymore, as long as, okay, so I mean here we do, how do I want to write this? Otherwise then we could just use it if we, okay. Why did I write this code like this? Okay, let me try to think. What's the cleanest way to do it? Okay, so then if we don't have it, then we still can do it. This is gonna be a mess, but why do I write my code like this? If we don't have enough. Otherwise, then, well, how did I do it last time? No, I mean, there's no subtractor. I didn't subtract here. That's fine. I think this is, yeah. All right, and let's give it a spin. It should, I want to say, maybe solve the, okay, maybe not. 355. I mean, I think it, I mean, we had the answer, but maybe I just kind of handle skipped in a weird way. But, oh, yeah. Because it just means that the input is the answer, so I just didn't really handle this in a good way. But, yeah. Okay, so then now if length of digits is equal to length of num, then we are done, and then we just return because we have went all the way, right? So we solved that one. But now we have to do this thing with maybe doing a recursive. How would I even think about it? I'm like really tired. Okay. So instead of this, we have def, I don't know, fill, I, maybe, right? Let's actually convert this back to the thing because let's see. Let's do a pure conversion first. I don't think we want to do the skip thing anymore. We always remove the skip thing. Oh no, I guess we did this still, but okay, so then we would call it with skipped here then, right? For the rest of the digits maybe. And it just means that to start, yeah, if skipped start is equal to 1, that's all it does. I think it doesn't matter anymore as long as we fill out the rest. Digit supply, and now hopefully this yeah, I just want to get this one working first for the other inputs. Okay, and then now if not good, then what does that mean? If not good, we just return false maybe. Otherwise, if how does this match up? Okay, if not good, then we return false maybe. Otherwise we return, what did I call this thing again? Fill I+1 skip, right? And then skip doesn't yield false anymore. We do if fill of 0 false, return to the join digits, something like that. Yeah, and then here if I is equal to n, then we return true and happy. Okay, I think I saw a place where I did an append back by whatever. This is what happens when you have code duplication in not a good way. Right. Let's give it a spin real quick. Oh, this is, so I didn't really find the answer. I was hoping that it would though. Oh, this is the case where it just didn't know. Right. Yeah, that's true. Okay, I mean, this is better than I expected, to be honest. But we can write whatever. This is just for debugging anyway. I mean, this should not be. Yeah, this is not. Oh, I just want to see the other responses to the other cases. That's why I kind of, you know, like I knew this one would be wrong, right? Because we didn't change anything. This is interesting though. No, I mean, I guess this is consistent with what I expect because we no longer that should return false. Oh wait, this is if this is true. If this is false, we don't print this out. Why do we care about this? Wait, yeah. Why do I have this? If linked with, oh, I think this is just by default true. It was my old actually it was this basically. So we don't even need it. Okay. Okay. we got this back. This is no good because same thing. This is what I wanted, the parity, right? Meaning that I converted my for loop into a recursive function, right? Tail recursion, straightforward for loop conversion. Just want to make sure that this is right, and we still pop. I mean, the same response, right? And then now, what happens? So if we have not seen one, if not good, then we return false. Okay, I see. So instead of tail recursion, now when we have good, we recurse. Right? So okay, I see. So then now we go. Maybe we should start with the beginning. Okay. I hate the way I wrote my code. So then we don't keep track of good anymore, because by definition, if it's just good, because then now we want the default to return false. Instead, what we are saying is that what we're saying is that in this case, this is good. Then we do a if I plus 1 skipped. Then we return true. Otherwise, if this is no good, then we set, let's just say we set this back to none for whatever reason. We get rid of this already. And then we do this thing back. And then we try the next number, right? Yeah. Something like this. Can still try this digit, right? So then fine. Return true. Otherwise, digits of I is equal to none, right? Okay. The way I'm paying for the fact that I implement this really poorly, I suppose. Min digits. Okay, yeah. Because if you have to copy and paste in 10 places to change something, it's a smell. I'm gonna YOLO submit. It's this video's been an hour 40 minutes. I'm gonna YOLO submit. Okay. 68. I think I'm not handling the 6 correctly because of the 2 and 3, but that's fine. We're making progress. This is like this is like a weird case, right? Meaning it's something that I might not have considered, which is possible. So 6, we delete 2. Oh, I see. Because this assumes, okay. How do I want to handle this? Because the thing is that I know the bug. I'm trying to think how to handle it. The thing is that we choose either this or this, but the 8 case and the 68 case is that it takes off a 2 but not a 3. Okay, I'm just lazy, so please forgive me. I do not recommend this. But this still does. It's not the same branching, but it's just a requirement checking. So this should be. But look, alright. I just want to see. Alright, YOLO submit. 20 is 2 times 2 times 5. Okay. I mean, we fixed the other one. Why doesn't it touch? So 85. So it tries 6, 7, 8, 8. Why doesn't it try? Or why is 8 doesn't work? Huh. So it tries. Maybe there is something weird though. But it tries 6 over 2 and 3. No. 7. No. 8. Okay. Why why doesn't that work? Okay. I mean, I think we're getting closer. I mean, we're not getting farther, and this is a mess. But okay. So let's take a look at 8. I think it's the same idea. Okay, I see. It's the same idea. Because an 8 requires 3 of these things. But we don't account for 2 or even 1 of these things. So we have to kind of figure it. This part, I mean, the 2 and 3 one is a little bit awkward. Everything is a little awkward. I am a little awkward. Okay, so let's just say delta is equal to min of need and half, right? Yeah, because we don't care that much as long as. Okay, I think the issue is just that making sure that we get it back. I think this is maybe okay. This one, the need is 1, so it's binary. I'm just auditing it now. This one is a mess. We probably could have wrote this in a cleaner way, to be honest. But all right, YOLO submit. I mean, it's YOLO submit like 3 times, so I don't, it's fine. It's not that YOLO anymore. I mean, maybe it's still YOLO, but it's YOLO 3 times. YOT. Okay. Anyway, okay. So 45 is 9. Do I not do 9 correctly? No, I mean 9 should be here, right? Am I not? Maybe this code is just still wrong. Which honestly, I would not be surprised. So we need this. We have half. So if half is less than, then we just do this. I guess we don't even need this anymore. Why was a skip is equal to true? Skip is equal to true is a little awkward now. I think maybe that's why. Because it's saying that because this I maybe that's why. All right, so 15 is 3 times 5, right? So we have a 5. We did do a we pick a 5 and we skipped, maybe. Okay, so it's here. I don't even know if I handle skip correctly, like the skip logic anymore. Okay, so we did a 5. We have a 5, so but we did skip on the 4. Do I do a 4 in a weird way? No. Well, I mean, probably twice, but then it just fails. So then skip is true. So it does 5, but the skip just makes it so that it tries 1. So it doesn't really matter. Or this should still be correct. Why is 53 not working on this? Alright, just put it out. This is not a good problem to start this late. Okay, so 4 is wrong. 1, 4 is 5, right? Okay, I mean that okay, all right, like that's expected. Wait. Huh. Why does that start with 5? Why is start 5? Start starts at 5 unless I skip, but skipped is force. Why is it force? Okay, yeah, no, okay. So it is a skip related problem. That's actually what I thought might be, because I think we no longer oh, I see. Because here, this part we need to do skip. Okay. That makes sense. Because we skipped the number because it's not true anymore, so we skipped it. So skip is equal to true. Okay, I see. Because now we do test all the numbers. Is it just here? No, I think it's here. I think if we don't return true, it's skip is equal to true. So we could probably just eliminate a lot of these and then just write skip is equal to true on the thing. I mean, these are all mutually exclusive anyway. Yeah. Because if we don't return, then skip is equal to true. I think that's the thing, right? And technically skip is just whether P is equal to start. Okay, yeah. Probably could have been this cleaner. Oh, I was hoping that pause was it, but 83 is wrong. Do I do something weird? Probably. I put 83. This is actually the opposite of the way that we've been going so far. What's 42? 6 and 7, so 237. 237. So that's definitely not right? How do I? Why is that? Why does the machine think it is right? Why did I remove that? I think I had some other stuff. I forgot what it is now. I was hoping, but yeah. So none, which makes sense. We haven't put anything in yet. It tries 7, no good. 7 in first digit, no good. So eventually it just crashes out on the second one, and then now it chooses an 8. Oh, this conditional is wrong. Then I think that's it. Okay, that's a way. How did that even happen? But basically, if sum of f dot values is greater than 0, return false. I think that's it. I don't know. That's such a basic check. How is that 790 things in? I don't know. But oh, it's still wrong though. Plain I skip digits. I guess it could have been here. Let's just do it here. Right? So 8, 3, not digits. Oh, not just digits. I want to see F. Do I not? So 7. We don't add back to 7 after it's force. That's basically the thing. So here, half is equal to need, but we can still try this digit. Half is equal to need. So we try the 7. What? Why don't? Oh. This is on the else for some reason. I mean, I rewrote this and I just missed a location. I mean, there's nothing too crazy about it. We still try this digit, but we don't subtract it in that branch. Checking out here, I think here we have to, oh no, yeah. I mean, I think whether, yeah, if it doesn't return, then we just do it. So I think, oh man, I'm paying for the sins of, yeah, okay. And I think here, I kind of saw it, but, did I also put skip? Oh no, I just put skip as you go to true everywhere, right? Well, like on top, so I think this is good. And I think this one, we have this, so this is good. We can still try this digit, but we don't subtract, so we don't restore it. Alright, let's go. Oh, I left in the print statement. Oh well, it's wrong anyway, so maybe I needed to come back. Ooh. 0 is definitely not right. How do we even start with 0? Huh? Did I just put in the wrong thing? Okay, so 302. Oh, start has to be yeah, okay. I mean, it has to be non-zero number, right? So I actually was thinking about this case much earlier on, but I just forgot. If start is equal to 0, start is equal to 1. That's it. But it might handle skip incorrectly. So, okay. So in this case, skip is always going to be true no matter what. Okay. I think that's good. Did I put it in? Yeah, it'll be easier to test if you put it in. Okay. Alright, this time I'll remember to remove the print statement though. If I could find it. Oh, there it is. I can. This is like an hour longer than I expect. Oh, how many wrong answers did I have last time? Okay, I did have a lot of wrong answers last time. I usually don't want to look it up. Why? So 27 is 3 cubed. So 6 takes 2 of. Oh, this is the 6 weirdness, right? Yeah, I mean, I have copy and paste typo. Okay, fine. That's. At least it's easy to. I mean, at that point, I was already kind of dubious. I should have rewritten that down, but anyway. Oh. Oh, yeah, I didn't know about this. I could just do this. I actually did know about this, but how many digits? 10 to whatever it is. Where's my? Let's use this test case. What is going on? Give me my buttons. And if I don't have it, just when this is how you actually test. Okay, that's good then. I'm a little bit lazy. We could have done other things with it. I don't know why it's just like in random place now. But yes. I mean, a lot of the wrong answers we could have avoided. I just had like minor. No, I mean, yes, I could have avoided them. I don't know if I actually would, but I mean, some of them are just like minor typos after we got the idea, and it's just from me not thinking about it through because I'm really tired. This video is 2 hours long. Yeah, I don't know if I solved it. I mean, I guess I probably did similar things last time. I have 4 wrong. Did I have the same? Yeah, that's funny. Only 4 wrong answers last time. This time I had 6 wrong answers, and a lot of them were just silly. Yeah, I don't know. What was my code from last time? Is it cleaner? Oh, I had the same DP, so I guess maybe that's it. Yeah. Well, I don't know about that. Okay, so it's just as messy last time. What is there to say? This is definitely could make it cleaner. That's for sure. But yeah, I don't know if you. I mean, I could show you my code. It is not. I don't know if there's anything to learn from my code. That's hint 1. Yes, hint 2. Shortest suffix that must be changed. That's interesting, actually. Yeah, I mean, that's what I try to do. Shortest suffix that must be changed is actually maybe a different thing, because then you could do a binary search. And then... that's interesting, maybe. But either way. Sorry, friends, I don't think my code is like that learnable, but I mean, I'll scroll down slowly. And then you could, see for yourself. This is my get min number thing. This is just a mess. I should have, if I knew I had so many craziness, I would not have done it differently for sure. I don't know. But it is linear time now. That's, something that I was trying a lot about. That's all I have for this one. Let me know what you think. Thanks for watching. I think so. The reason why I hesitate for so long is that I thought this recursion would branch, like exponential branch out. But once if this is true, and there are different versions of it everywhere. But if this is true, that means that it's either this is true, or the next, if there's a next permutation, it's going to be true. Well, it's not quite the next permutation, but the next, like, the increment on one of the digits is true. And it's kind of what hint 2 is about, right? It's either, so for each digit, you either increment or you don't increment. But they're all correlated, right? Because you never, if you increment on one of the digit, you'll never need to increment for the rest of them. So if this is true and this is false, then it is going to be true for the next number, if there's a number, right? And what I mean by if there's a number is that, in the case of the issue that we were debugging, where if we have 1488, here there is no, if you just look at the 4 part, if we do this, there's no next number, right? Because 88 is the max number of the digits left. So that's why you have to go back. But here, the next number, maybe it's 6 actually. Well, 6 would be a possible, like if I do the math, but it doesn't, right? Because here, then we just don't have enough digits for the rest, so it automatically fails. And it goes to 8 as the next number so that's the number we increment to. And then here, the rest we can just do 48. And we always, if this is a possible number, then this is always the answer. The next one will always be true because you're only going down this way as a prefix, right? If you don't increment. And I think that's kind of the idea behind this problem, or that keeps it linear. It took me a while to think about it, but that's it. That's all I have for this one. Look, usually I would say watch the older video. Maybe it's a little bit better. I don't even think that's true, but for today, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'm passing out. I'll see you later and take care. Bye bye.